Okay, this is the first one definition for the force. We also can say pull and push. Sometimes the question they put simple one. Okay, definition for the force, push and pull also can. Okay, so sometimes they give the short one, then the longest one should be this one. The force defined as anything that will change the state, either rest or motion of an object moving in a straight line. So this one is another definition for the force. So this one can be accepted, this one also can be accepted. Okay, force we cannot mention about the formula, although we know the formula, but we cannot explain the formula. Okay, for example, force. We got so many different type of the force. So the first one we know gravitational force. Okay, before that we know already the falling of the gravity. We pull go down. Why the weight is always go down? Because they pull by the gravitational force. So that means there's an attractive force of the earth, okay, for any object. So we got another example force. We got weight. So normally we are mass, is it? Mass, that's in kilogram. Okay, if you say about the force, force already is Newton. So from here, we need to convert our weight become the Newton by using this formula. Okay, suppose we write W equal mg. Okay, m is your mass. So this one is a gravitational force. Okay, so from here for the kilogram, you go become gram. This one is a mass. Okay, gravitational force causes all the object to have the weight. Okay, because pulled by gravitational force, so that's why we got weight. There's a magnitude strength of the gravitational force acting to the object. So that's why they got the formula W equal mg. So this one is a one type of the force. Okay, but we call it as a weight. Okay. Okay, example, another one, we also got force. Okay, normal force. Okay, normal force normally acting upwards. So this one we call normal. Okay, sometimes called force, sometimes we call normal reaction. Okay, down, everybody know there's a weight. So now when the object is stationary, the boat is stationary on the table. So that means I got two forces acting to the boat. First one is a normal reaction. Second one is a weight. So these first and second, the force must be equal. So that's why the boat is balanced. The force is a balance and also rests on the table. Okay, so for example, this one normal force refer to the force that's perpendicular to the surface. Okay, the normal force perpendicular to the surface. This one is a surface, so the 90 degrees perpendicular to the surface where the object is placed. So normally we're talking like this. This one is a normal, this one is a surface, so there's a 90 degree. So this one we call perpendicular to the surface. This one we call normal force. Okay, we got another force they call friction. Friction force is one type of the force. And also they always opposite the direction of the motion object. So now the ball you want to move to the right hand side. They got one of the force prevent. They don't want the ball go forward. So they call friction. So normally friction is the opposite direction. So when the object just moving on the surface, friction is the force that's oppose the motion of the object. So sometimes the object they're moving, trolley, they're moving on the uneven surface. So they got friction. So that means you find the trolley when starting very fast, then later they move, okay, until the uneven surface, they will slow down. So because got friction. So finally, they slow down. So friction also one type of the force. Okay, now we got another example. We call elastic force. Okay, elastic force normally for the elasticity material. Okay, for example, spring. Okay, spring that means you can pull it longer. After that, you can go back to the original shape. So this one we call elastic force. You apply the force to the spring, we call elastic force. Then after that, the object, after you return the force, they will go back to the original shape. So this one we call elastic force. So that means we introduce so many force already. Gravitational force. After that, you got elastic force. After that, you got the pulling force. After that, you got before that, we learn about the what? Okay, we learn about the friction. We learn about the tension. This all is the force, but we never call it as a force. They got another name. So this one name also represent by the force. Okay, now we're going to see another force. Therefore, the lifting when object is floating up. So this one we call up thrust. Okay, the force is acting upwards. When something object can float because got the water force. This one water force we call it as a up thrust. Okay, sometimes they say buoyancy. Okay, so this one is a force acting on the object immersed in the water. Okay, immersed in the water. After that, you got one force to support the object, then the object can be float. So this one also is one of the force. Okay, remember the aeroplane to fly, to move. Okay, we got weight, then we got normal reaction, is it? Forward, we got thrust. Then behind, we got drag. Drag also is a force. Okay, thrust also is a force. So this one is a one of the name. We never call force, but we're using another name to represent. So this one is acting upward. This one also is a force, buoyant force. This one is called buoyant force. Okay, so we're going to introduce more. So many examples. Just now we showed of force. Now we're going to see the force characteristic. Okay, force is a vector quantities. That means they got magnitude, then they got direction. So that means if you get negative force, that means the meaning is the force acting in opposite direction. Okay, SI unit. Okay, you can using Newton. Okay, straightforward using the N, or you can using kg, ms, -2. Kg stands for the mass. Ms -2 is a A. So this one is a formula from the force lah. Okay, we measure by using spring balance. So this one's the equipment. Okay, we want to use to measure the force. Okay, now you can see the equipment. Okay, this one is an example equipment. So we just hang. So they got mentioned spring balance. Okay, you can see here, Newton. Exactly to measure Newton. They show you there's a Newton. Okay, so when you just hang at the bottom, so this one just like the spring, they will move downward. When they move downward, that means they show what's the reading. Okay, now we're going to show one example. Okay, this one is the one how to take the measurement by using the spring balance. Okay, they start from here. Okay, wait. Okay, so they're using the slaughter weight. This one's slaughter weight. Okay, so they hang the slaughter weight at the bottom. So you can see they show the reading already. Okay, here they show about gram. Here is a 1 Newton. So that means just now we show the video. 100 gram actually is a 1 Newton. Agree or not? Because 1000 gram is a 1 kg. So 1 kg, how you change become Newton? When I change become Newton, we have 10 Newton, is it? So that's why 100 gram actually is a 1 Newton. 1 kg is a 10 Newton. So that's why this one we no need to convert. Straightforward, you hang, they will show you what is the reading in Newton. Okay, but they got maximum. You see, they until 2.5 only. Okay, maximum until 2.5. So that means the spring must be elastic lah. That means they can extend. After that, must be strong. The spring must be strong. So that's why they can do over using. Okay, over elastic limit. When they just over elastic limit, that means the spring inside the spring balance cannot go back to the original size. Okay, so this one is a one of the equipment. Okay, now you see the effect of the force. Okay, the force act on the object, the effect can change. Okay, When I just apply the force for certain object, okay, you can find what changes. First one, sure, the size can change. Example, the sponge. Use the sponge, you're going to squeeze the sponge. So the sponge changes the size. Okay, shape also can. Plasticine. I go to press about plasticine. Plasticine also will change the size. Okay, stationary state. The object is stationary. Then I apply the force. I'm going to pull the force, push it, then the trolley can move. So that one is a stationary state. You change become motion state. Speed, you also can be increasing the speed. Okay, the ball just come, you kick the ball, then the ball move faster. So that one is a speed. Direction, you also can change. Okay, when the ball just come, you change the direction, you kick another direction. So this one is an effect, can be changes by the force. Okay, the bicycle, you want to move faster, then after that you produce a higher force lah. Okay, after that, this one is a sponge. You can reform the size. Okay, this one you can pull the slaughter weight up and also down. So this one is a one of the thing related with the force. So this one you can see direction up, down, they can change. Okay, so this one, the plane can be moved forward because you apply the force. Thrust is higher, so they move forward. So this one is a one of the effect, okay, because of the force. Okay, what cannot changes by the force? Remember, there's a mass. Mass is totally cannot changes by anything. Okay, although you are go another way, you go to other country, you come back, maybe you diet, you reduce your mass lah, but the forces cannot reduce the mass, cannot change the mass. Okay, balance force. Okay, we need to discuss about two. One is a balance force, another one is an unbalanced force. Okay, we see what's the differences. Okay, balance force. When the force acting to the object is balanced, they will cancel each other out. So that means, example, one object rest, up is a normal reaction, down is a weight. So if I say this one is a balance force, that means normal reaction sure equal to the weight. Finally, one is a positive, one is a negative. So we cancel each other. So this one is meaning for cancel each other. The value must be the same. Just the direction is a different. So we cancel each other. So they become balance force. Okay, so balance force, another meaning we can say net force equals 0. What means of the net? Net means the last one. Total, you cannot discount already. You go to buy anything, they say net price. Net price means cannot discount already. There's a last already. So that means the last force, when there's a balance, there's a 0. Okay, don't have any forces acting to the object. So what situation we call there's a balance force? Okay, we can see stationary. When the object is rest, we call there's a balance force. Why? Because we follow the formula F equal ma. So you want to get the F, you must have the A. Mass, sure you got. Any object also got mass. The problem is a A. If you got value A, sure you get the force, is it? But stationary, the V already is a 0. So understood, A also must 0 lah. No velocity, where got acceleration? So from this one situation, no force. Because you know acceleration. So I cannot do any calculation for the force. Okay, another situation is moving uniform velocity. Now I got moving already, but still no force. Still balance. Why? Okay, because the object is moving in front and also friction. Okay, friction is go backwards. So that means you're moving in front 5 Newton. Friction also is a 5 Newton. You're still moving, but constant velocity. Constant velocity means what? Acceleration equals 0. That means you don't have any pickup. From starting until ending, your speed is the same. So the one we call no acceleration. If no acceleration, that means we also don't have any forces acting to the object. Okay, if got forces, that means your car become accelerate already, become faster already. So if don't have any force exert to the object, that means they will continuous to move constant velocity. Okay, so that means we only got two situation: stationary, uniform velocity. Okay, because there's a no acceleration. Okay, example, stationary. The object is stationary on the table. So now we got two forces acting to this object. Okay, the first one sure up, normal reaction. After that, another one should be the weight. Okay, then we go, the object is moving. The plane is moving. So the keyword is constant velocity. So constant velocity, after that got moving. Moving, we must including in front and behind. If the object is rest, we only up, down. Okay, if they're moving up, down, left, right. So from here up, we still normal reaction. But this one is a plane. Plane is a lift because they want to lift up. So down is a weight. Okay, front is a thrust. Okay, and the behind is a drag. So now I can say the equation is lift equal weight. Okay, after that, uniform velocity, drag equal thrust. Okay, so this one is a meaning for constant velocity. Okay, sometimes students will ask, constant velocity, is it a lift and weight is the same? So the question need to add one more. Same height. If they say same height, yes. Lift and weight is the same. If they never say same height, we can say L and W can be different. Maybe you keep up. Okay, but left, right is the same. If I say constant velocity. Okay, because constant velocity is talking about the motion, not about up and down. Okay, now you see unbalanced. If I say unbalanced, so the net force, okay, no more zero. Okay, the net force cannot become zero already. The net force sure got value. Okay, sure got value, then the object must move it. Okay, now we're going to see when the force acting on the object, there's a not balance, they must a net force. Finally, must have the net force. Then the net force, we call it as a unbalanced force. Or you can say there's a resultant force. So after you minus, after you plus, finally you show the answer. So this one answer, we call it as a unbalanced force. Or you can say there's a resultant force. Okay, effect. Okay, if you got resultant force, what's the effect? That can change the state of the rest. Maybe the object rests, then you change the situation. So the object will be accelerate. Okay, when starting your constant velocity. After that, you press the pedal. After that, you find it go faster. When it go faster, that means you apply the force already. You apply the force, now the situation become unbalanced. So the car can be accelerate. Or you can say change the state of motion. Okay, when starting very fast one, then you see the traffic light in front you turn red already, then you want to slow down. So after that, you make your car become slow down. You press about the brake. So finally, you see the moving object, you decelerate, and also maybe you want to change the direction, then you turn your steering, then you change the direction. So like this, we call it unbalanced already, because you already apply some force to the same system. Okay, so this one diagram, they show you about the unbalanced force lah. They push, and the trolley can be moved. And you just start, the bus can be moved, and this one pulling. When the something is moving, that means we call unbalanced force. So unbalanced force means you got net force, you got resultant force. So resultant force. Okay, now this one is a definition for resultant force. Okay, this one question always come out. They ask you what means of resultant force. So you must say resultant force on the object is overall forces resulting from the combination of the individual force acting upon the object. So that means you need to add all the forces. Okay, all the forces you need to add. Finally, you only left one. So that one we call resultant force. Okay, example. Okay, this one lawn mover, they go to press. Not press, push. They go to push the lawn mover. Okay, now this one is one of the force go downwards, but with anchor. Okay, with the anchor one, that means we cannot say, oh, I plus together. No, this one we need to solve. Okay, but this one is a form 5. Just I show you. Okay, inclined plane, that means we need to create the horizontal line and vertical line. So example, the object in front, behind. This one like this, we can plus, we can minus 5 Newton, 2 Newton. After that, you say 5 minus 2. Okay, no problem. Okay, if I got another one, 3 Newton. So you cannot say, oh, 5 minus 3. Cannot. Because your direction is a different. Okay, up and down, okay. Left and right, okay. Okay, but you cannot say up and left together plus. No, cannot. Okay, I also got another one like this one. You also cannot, because they got with anchor. With anchor one, we need to separate. Separate, make it become horizontal and also vertical. So this one is one of the example. Okay, so because they with anchor, they must tell you the anchor how many is 30. So I separate with the horizontal and also vertical. Later, we need to using your mathematics, sine and cos to settle it. Okay, so this one is a form 5. We need to find out about the resultant force. But form 4 syllabus still don't have lah. Okay, so from here we can see some more. Okay, this one is introduce for the Newton of motion. Okay, wait. Newton of motion. Okay, Newton of the motion, we got 3. Okay, 3 Newton of motion. Okay, now we see what is that. Okay, the first one I think I introduced already. Newton law of motion. The first one, there's an object remain at the rest. Or you say they continue to a constant speed in a straight line. Unless they're acting by the unbalanced force. So that means the object, they don't want to change one. If they're moving, they want to continue to move. Unless you go to force it. Then they terpaksa to stop. So this one, the concept same like the inertia. Okay, concept is inertia, but the law is a Newton first law. Okay, Newton first law is an overall one. Then the inertia is under Newton first law. Okay, then we go and see Newton's second law. Newton's second law is what we learned today. Okay, you see they say the acceleration of the body, there's a A, directly proportional to the net force. I mean A directly proportional with the force. Okay, and also inversely proportional to the mass. A inversely proportional with the mass. So we need to write like this. Inversely. So inversely, I need to put directly, I need to 1 over M. Okay, so now I want to combine these two formula. F equal, okay, this one, A, I put here. So I need to directly. So that means this one must be, A is here. Then the M is this one. M and A is inversely. But if I say force and mass, directly proportional. So you also can say F directly proportional with the mass. Only the M and A is inversely. So remember the formula. Okay, I create one formula. W. Force multiply displacement. Okay, so you see this one formula. W directly proportional with the force. W directly proportional with the displacement. Okay, but now F and S is together one. F, S together one, is it? So one up, another one must be down. Okay, then your W become constant, is it? So that means when you see the physical quantity is together one, so must be inversely proportional. So you can see the MA. M increase. If your mass become increased, so your acceleration should slow down. Okay, just like the common sense, like the trolley, you go and buy grocery. So if you buy the grocery full already, the trolley full already. So what you think about the acceleration? The acceleration should become slow down. Okay, when the force constant. Okay, when you apply the force is a constant. So this one is a Newton's second law. Okay, actually same like what we learned today. F equal ma. Okay, then we go Newton third law. Okay, Newton third law, you can see the situation. They say for every action, Okay, any action and equal but opposite reaction. So this one just like what we learned for the explosion. Okay, remember the bomb? Okay, when starting zero momentum. Okay, after they start to bomb, wow, everything out. Okay, they just like react to any direction. Okay, after that, the value is equal. Okay, so this one concept actually is an explosion. Okay, when starting is okay, 0, 1. Okay, when they just start to bomb, start to fire, that means any direction also got, but the direction different. The value is the same. So this one we call Newton's third law. So they say every action there's an equal and opposite reaction. Okay, so this one is a Newton law of motion. You only got 3, you don't have 4, 5, 6. So remember the first law is talking about inertia. Second law is talking about F equal ma. And the third law is talking about explosion. But when the question asks you what's a Newton third law, you cannot say explosion. You need to give the explanation for the Newton third law. Okay, I just related for you. This one law is using to what concept? Okay, so this one is a Newton law of motions. Okay, now we need to find relationship. Force, mass, and acceleration. So that means we need to find out F equal ma. These 3 physical quantity, what's the relationship? Okay, when a net force act on the mass, okay, it will cause acceleration. So the 3 things is together one. When I apply the force, then the object sure got the mass. Finally, the object can be moved, so they got acceleration. Okay, so F equal ma. This one is this topic, the formula, mass multiply acceleration. So the acceleration is directly proportional with the force. So that means if I apply bigger force, so what happened? The acceleration become increased. The trolley mass constant, only one box. So I push the force bigger, so the trolley can go faster. So there's a directly proportional. Okay, if I plot the graph, F versus A, directly proportional, pass through origin. Okay, now we're going to see another relationship. Acceleration and also mass. So you think about the logic also can. When the mass increasing, the trolley is full with grocery, then your force constant. What you think about the acceleration? Sure drop. So there's an inversely proportional to the object. So we can plot the graph also later. So the direction of the acceleration is same as the net force. Okay, if I say the force is go to the right, later the acceleration also follow the direction, go to the right. Okay, they depend the force applied. Okay, so if I want to plot the graph, A inversely proportional to the N. Okay, inversely, remember, you can see when the curve here never touch one. No touching. We no touching for the Y and no touching for the X. Okay, if I want to convert, become directly graph, you need to change 1 over M. So A directly proportional with 1 over M, actually same like the inversely proportional. Inversely proportional A and also M. Okay, that's the same meaning. Okay, inversely proportional, we don't have the symbol, so I cannot draw. Okay, we only got symbol directly proportional. Okay, now we see the example 1. Okay, find the acceleration of the object. So we apply formula to find the acceleration. I say F equal ma. Okay, so this one is a 10. Mass is a 5. So I find the A lah. So finally, your A also follow direction of the force. So from here, I get it. There's a 2 ms negative 2. Okay, so just a simple question. This one is from your exercise. The notes there, example 1. Okay, then we go and see the B. Okay, B got two forces acting to the block. Okay, right you got 45, left I got 15. Normally we take the biggest one is a positive direction. Because final answer I do want got negative. So from here I need to take 45 minus 15. Okay, 15 is a friction. Okay, after that 3 is a box mass, then the acceleration. Finally, sure the box got moving because your pulling force is a bigger. So I get it 10 ms negative 2. Okay, find the value of the F. Okay, the question not only find acceleration, they also can find the F. Okay, the diagram like this. They give you the acceleration. If they give you acceleration, means this one is unbalanced. Okay, unbalanced means got moving already. Sure, this one F bigger. Bigger than the 5 Newton. Because you got move already, is it? Okay, so from here I need to show F minus 5. Because F is bigger than the 5. Then 10, then after that got 4. So I get it. My pulling force is how many? 45 Newton. Okay, 45 Newton, then I overcome the friction 5 Newton. Then the box is moving by 4 ms, negative 2 acceleration. Okay, then we go this one C. Find the value of the M. Okay, M is what? Okay, find the value of the mass. This one is a mass. Okay, we do know the mass of the object, but I know they got pull 60 Newton. This one is a friction. Then I got acceleration. So sure they follow the direction of the box. There's a go to the right hand side. Follow the force. So we just apply 60 minus 10 equal the mass, then 2 acceleration. So 50 over 2, I get 25 kilograms. Okay, then we continue to the example 3. Example 3 suppose is your example 2, I think. Okay, you can check your example 2. Okay, a trolley of the mass 30 kg. Okay, important, write the info first. Okay, mass 30 kg. Pull along ground, horizontal force 50 Newton. The opposing friction, they tell you opposing friction. Means there's an opposite direction. The force is a 20 Newton. Calculate the acceleration. They want to calculate A. So we got info. Okay, mass, force, friction, then A. So we just write the calculation, F equal MA. But the problem here, I got 2F, is it? I got force, I got friction. So 50 must minus 20. Okay, 50 minus 20. After that, the mass is a 30. So A. So after that, I find it 1 ms negative 2. Important, the unit. Must write the unit. Thank you.